Hi everyone. So this is lesson 1-5 from your textbook on equation solving and properties. And really by this point in your mathematical career, we assume that you know how to solve an algebraic equation. Okay, you've seen this lots of times before. So really this lesson focuses on some of the trickier stuff that you might see in a lesson like this, like how do we deal with fractions, how do we deal with these crazy decimals, negative signs, things like that. So instead of looking at this as let's learn how to solve an equation, this is more me giving you some advice for how to deal with some of the harder stuff you're going to encounter. So let's take a look at this first one, for example. All those fractions are terrible. And could you find common denominators and subtract the 3/5 from the 11/10? Sure, I believe that you could. You could also do this with a calculator. But there is a method called clearing the fractions, and I'm going to make a note of that just so you know that that's what I'm referring to, that I'm going to use on this first one, that you're going to find useful for several of the problems you're going to be asked to do. Okay, so what I'm about to do is called clearing the fractions. And here's what I'm looking at. I'm looking at the denominators of the fractions, 6, 5, and 10. And I want to find something that those all divide into. Okay, kind of like finding a common denominator. So 6, 5, and 10, the smallest thing I can think of that would work is probably 30. All of those divide into 30. But instead of rewriting this as 25 over 30 or whatever it might happen to be, I'm going to take this entire equation and multiply it by 30. And really, I'm multiplying by 30 on both sides, okay? And so when I multiply by that 30, something kind of crazy is going to happen. I'm going to show you how to do this on your calculator because some of these might be tough to do in your head. When I go to do 30 times 5 over 6, here's how I'm typing that in. 30 times 5 over 6. And you'll notice I get 25. So this is equal to 25 plus, now I'm doing 30 times 3 over 5. 30 times 3 divided by 5. I end up with 18. And then I'm doing this over here. 30 times 11 over 10 should come out to be 33, but 30 times 11 divided by 10 would be 33. And so by doing that, what I've done is I've kept the equation equivalent, right, because I did it to both sides. But now I'm left with an equation that's much, much easier to solve, okay? So when I'm looking at something like this, my first goal, after getting rid of all those ugly fractions, would be to get my x's together, right? I need to somehow get those combined. And they're on different sides of the equal sign. So if I want to pick up this 18 and move it over here, I have to do it by subtracting 18x. Okay. And so over here now I'm left with 25 equals, and then let's see, 33 minus 18 I believe is 15. Okay. And then divide both sides by the 15. Okay. And then here's one more thing I want to point out. When I divide this, 25 divided by 15, I get this crazy answer, right? 1.6 repeating. I don't love that as an answer. I get that I could write that down as 1.6 repeating. What I wouldn't want to see is something like 1.7. I get that you can round that, but we have a way that we could be more exact about it. I would really prefer this answer back as a fraction. When you have these ugly decimals, these repeating decimals like this, it's really better mathematically to write them in fraction form. And I'm going to kind of emphasize that as the year goes on. So here's what you can do. If you want to put this back in fraction form, once you've got this decimal here in your calculator, I'm going to hit the math button. Move this so you can see it. Math. My buttons are sticky. And then right under math, that very first option, hard to see on mine, but it says FRAC for fraction. So I'm going to choose that. And then just hit enter one more time. And you'll notice that that comes out to be 5 over 3. So as an answer, I'm going to put x equals 5 over 3. And I like that answer way better than 1.6 repeating. Okay? Again, what I would not want to see is something like 1.7 or 1.67, okay? Even if you do like 1.6667, okay? I don't want to see that because none of these are actually equivalent to 5 over 3. The only thing that is equivalent to 5 over 3 would be 1.6 repeating. And I would take that answer. That one would be okay with me. But I don't love it because if I had to then take that number and do something else with it, it's awfully hard to type an infinite number of sixes back into my calculator. But I can work with this number. That's why we like this better. Okay, rant complete. Let's look at number 2. So number 2 also has fractions in it. So I'm going to use that same method I used a second ago, the clearing of the fractions. Again, I realize some of you might be able to get away without it, but I'm going to multiply everything here by something that both 4 and 2 go into. Okay, so I'm going to multiply everything by 8. Okay, multiply by 8 on both sides. When I multiply here by 8, I'm going to write out this next step. Just know that I normally wouldn't write this down, but I want you to see what I'm doing. This thing here becomes 8 times x divided by 4. And this thing here becomes 8 times x divided by 2. And then here I get negative 15 times 8, which I'll simplify in just a second. So again, I normally wouldn't take the time to write that step down, but I wanted you to see what I'm doing. Because what's going to happen here is 8 divided by 4 makes 2. And 8 divided by 2 makes 4. And 15 times 8 is negative 120. And this time, because these are on the same side of that equal sign, I can just go ahead and combine those two things together. I don't have to move them like I did up here with the 18. I can just say this is 6x equals negative 120. And then divide by the 6, and I end up with x equals negative 20. Okay. All right, let's take a look at example number 3. Now, there is a method that I could show you with example 3 where we could clear the decimals, kind of like we cleared the fractions up above. I don't know that it's super useful because I feel like now with calculators, we don't need to worry about messy decimals. We can work with them. That being said, there is a mistake that shows up in this problem over and over and over again. And there's one very similar to this on your first quiz. And so the reason I put this example on there is specifically for that first quiz. So you may want to put a little mark next to it so you remember to come back and study it later. Okay, so when you see a problem like this, the first thing we need to attack is this parentheses. And specifically, this number sitting out here with the parentheses, right? This number needs to be distributed, okay? But what you have to remember is that that's actually a negative 0.3 that I'm distributing in here to the 20 and to the 2x. So if I were to rewrite this thing, the 0.45x is going to stay exactly the same. And then I'm going to do negative 0.3 times 20, and I end up with negative 6. And then I'm going to do negative 0.3 times 2, and I get negative 0.6. But do you see how both of those are now negative? That's because that negative sign got spread inside the parentheses, and that's what has to happen here. Okay, equals negative 81. Then we're going to combine our like terms, and our like terms are this 0.45x and this negative 0.6x. But don't forget about that negative, okay? So when I go to put these two things together, this is how I'm doing it. And a lot of this I'm showing on the calculator, not because I would need a calculator to do it necessarily, but I want you to see the calculation that I'm doing. 0.45 minus 0.6, okay? That's what this is saying, 0.45 minus 0.6. And I end up with negative 0.15. So these two together make negative 0.15, and that's with an x on it, minus 6 equals negative 81. Okay? And now it's just a matter of moving numbers away from this x. So the x is what we're trying to get by itself, right? the first thing I'm going to move out of the way is this minus 6, and I'm going to move it with a plus. So I'm going to go plus 6 and plus 6. Okay. That's going to leave me with, this cancels, negative 0.15x equals negative 75. And then I'm going to divide by that negative 0.15. And I end up with x equals, sorry, my buttons are sticking a little bit, x equals 500. Now that one was maybe a little bit trickier to get to the final answer on, so maybe we need to go back and check our work, okay? So here's what I'm going to do. I'm going to look at that original equation, but anywhere I see an x, I'm going to replace it with a 500. So I'm going to go 0.45 times 500, and notice how I'm putting it in parentheses every time when I put it in the calculator, okay? That's just a good habit to get into. Minus 0.3 parentheses 20 plus 2 times 500. Now this is a little weird. There's the parenthesis for the 500, and there's the parenthesis to close this parenthesis, okay? And I'm hoping a lot that it comes out to equal that negative 81. Voila, it does. So we were right the whole time. Okay? So just keep that in mind. With these equations, you can always use that method. All right, one more to do here. So here we've got some distributive property going on, right? So on either side, I'm going to distribute. And so here I end up with 12x minus 8 equals, distribute here, 12x plus 10. Some of you might be noticing something a little weird right here. I'll get to that in just a second. But in normal situations, when I end up with x's on both sides of the equal sign, my first order that I need to do, the first thing that I need to worry about is getting those x's together. So picking up one of those x's and moving it to the other side with the other. You can make an argument. Some people like to move the 8 over to the other side first. Mathematically, it doesn't matter, but there's a lot of situations where I think it's easier to move the x first. So I always start with this, okay? And which one do we want to pick up and move? Well, maybe we're going to move this one. So I'm going to subtract 12x to make that cancel. Now, when I come over here, this is a little bit weird. This one also cancels. That doesn't normally happen, okay? Normally, we're left with some x's on this side. But we didn't get any, which means right now my equation says this. Negative 8 equals 10. And that's not true, right? Ever. So what this means when this result happens, this means no solution, okay? It means that there is no value of x that could ever make these two things be equal to each other. And you may have caught that back here when you noticed that they both had 12 x's in them, but chances are you won't notice it until you actually get rid of the x's, okay? So if you get rid of the x's on both sides and you're left with just two numbers that are not equal to each other, that's what this means, okay? No solution. Just for reference, as I didn't put one of these examples in here, but if we had done this same thing and ended up in a situation where we had two of the same numbers, if we ended up with like 5 equals 5, that means that x can be anything. That means that x can be any number you choose. And so that would mean your solution is all real numbers. Okay? So that's the difference. This one was supposed to be no solution. But if something like this were to happen, it would be all real numbers or infinitely many solutions. Okay? Okay, so that's it for this part of the video. There is a second video that covers the word problems on the back of the page. So you can go ahead and get to those, and then your homework for tonight is Lesson Master 1-5B.